is a screencast where I'm going to be doing the next Everybody Codes quest. Now, I know that my last screencast was of quest 9, and I've done a few quests in the meantime. Honestly, what happened is that quest 10 just took me so incredibly long that something went wrong with the snipping tool and it just didn't work. I don't know, it was recording for like 2 hours, 2.5 hours, and it just fell over. So, lesson to self, put stuff in separate videos if that's going to happen. And then, then I just decided, okay, let me just do a few things on my own. And the ones on my own, they didn't take that long. Until I got to quest 15. Quest 15 took a long time to get right, and I'm still not happy with my answer to quest 15. If I bring up the PowerShell and make sure I have, go build. Let's make sure I have executables for everything. Most of the quests take under 2 seconds, and quest 15 currently takes 45 seconds to complete. But it's way better than it was when I started, when it was taking hours, and my first attempt at a solution that I'm pretty sure would work if I just let it go forever did not have a solution overnight, so it was pretty bad. That was just part 3 of quest 15 that was so bad. But and if I ampersand, and what I want to say here is measure command out default dot right. So this is running each of the quests. You know what? I should say what quest it is. So most of the quests are way down in the partial seconds range, and then we get to quest 15. So let's see. Before that, we've got this. We've got that. That's a little slow. That quest 7. Quest 12. Here was that long. That's still a little long. And then quest 15, and it's just as I said, it ends up at like 45 seconds. I've got an idea that I think will make quest 15 much faster. I might do a screencast on that, but it's probably going to be very confusing if I do. I mean, for the 3 people that are going to watch this anyway. The reason is that I'll have to go through and explain what Quest 15 is in detail and what I'm doing and how my existing solution works, and then I'll be able to explain what's going on there. And I cannot remember when I started Quest 15. Oh, well, there it is, done. Oh, wow. It took 95 seconds that time. That's... I thought it was in the 45-second range. Well, in any case. Yeah, but then Quest 16, just that. So, and I actually think I can shave maybe 0.3 seconds off Quest 16 with... there's something I can do to avoid repeating some work that should help there. But yeah, I've got an idea that I think could really strip down Quest 15's time, and I'll do that at some point. But this time, what I want to do is I want to do Quest 17. I have no idea what Quest 17 is. If it gets to where the screencast starts taking into the hour-and-a-half range, I will stop it and make a new video, just so that I don't end up losing the thing again. Again, for my big audience of 5 people or whatever. Okay, so part 1. Stars are an excellent form of navigation system. Knowledge of them allows travelers to determine the exact location of places. Let's see. All constellations. Oh. How to measure the distance. Each star has coordinates set to find its position in space to calculate the distance. Absolute difference of their S coordinates, absolute difference of their Y coordinates, then some of these differences. So Manhattan distance. Algorithm from, yes, Manhattan distance. A constellation group of stars forms a single structure so that the sum of all distances between connected stars is as low as possible. Also, as few connections as necessary to maintain connectivity. Okay. It's the size of the constellations. Number of stars forming a constellation combined with the sum of distances between connected stars. The sky is exceptionally clear and dark tonight. Ideal conditions for astronomy condition. Create a constellation from all these stars and determine the size. Okay, so we have all these stars. And as few connections as necessary to maintain. There are 4 connections with the distances as follows. 3, distance 3. 2 and 3, distance 3. 3 and 5, distance 3. 5. 11. The lowest possible size. So only this is considered an actual constellation. So basically I have to find a spanning tree among the stars, and we have to find the spanning tree with the smallest possible Manhattan distance sum. Okay. And for some reason then add the number of stars, which seems kind of silly. Since there's only one. Connection. Oh, and I should have done this before I opened the problem. I did not go and create my skeleton, so let me go in here, create my skeleton, code Quest 17, and for this I'm gonna copy over. Actually, I'm going to copy over the main from Quest 16, because that was a pretty good main. Copy. New file. Okay, and now here we have do problem 1. String 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 and instead of panicking, we are just going to return okay, and this so let's take a look at our input here. 17 1. Okay, so those are all the stars, and I mean, I can, as a human, I can kind of see what the spanning tree is. I'm not entirely sure how to make a spanning tree programmatically. I guess we'll try to find out. But first thing we got to do is we got to get all these stars, and we got to get them into a set of points, I'm guessing. Yeah. So type point struct x, y, int. Okay, so scanner is buff.io dot new scanner of bytes dot new reader of data. Then stars make map point bool for scanner dot scan zero for call index ch call equals range scanner text. Then we have stars at point of height column true if ch is a star, then that. Okay, and here we do height. Okay, let's see. So now we have all the stars there. Can we just I mean, yeah, I can say that, okay, well, we're going to want to branch out from that central star, but I don't know how to, God, you gotta make the spanning tree. Make a spanning tree with the smallest distance. Okay, so first let's get all of the distances. Actually, why don't I make it so that we have yeah, let's put all the stars not into a map. Let's make them into an array, well, slice. And here I say stars append point okay, and now distances, make stars for I, comma, star I in range stars for j, comma, star j range stars. Oh. So this is a little bit annoying. Go does not have an absolute value function, except for like big ints or something, or not even. I don't know. It doesn't have a nice little built-in absolute value function for ints, which is kind of bizarre given how max and min are baked in deeply into the compiler. But okay. So here we'll have row make int 0 when stars distances dot append row, and this will be row dot append. Yeah, so this is the of star I dot x minus star j dot x plus abs star I dot y minus star j dot y. Okay, and now, and you're right, I didn't need those variables. Good point, compiler. Okay, so now I have the distances. Now, what do I do with them? I don't know any spanning tree algorithms. So I hate to do this because this is kind of ugly and nobody wants to like watch somebody Googling stuff. Like that's kind of stupid, but I guess I'm gonna have to. Wilson's algorithm can be used to internally build this. Let's do that. Gradually build a spanning tree. Intermediate steps of the process of finding. Okay. And polynomial time message. Okay, let's minimal spanning tree. Algorithms, classic algorithms. Check. Forest F, consider minimum weight. G back. One edge, an arbitrary vertex. Each step's T is least weight edge XY such that X is in T and Y is not yet in T. Okay, so I think this works. Greedy algorithm, minimum spanning tree. Total weight of the edges is minimized. That's what I want. Building this tree one vertex at a time for arbitrary. Okay. Initialize tree with a single vertex chosen arbitrarily from the graph. Grow the tree by one edge. Of the edges that connect the tree, find the minimum weight edge. Transfer it to the tree. Really? That's it? Okay. Huh. That I can do. So, what I need is edges that are in the graph and edges that are not in the graph. So I'm going to need I'm going to need two sets. So these are points in tree, point. Do I want points? No, I don't want points. I want ints, where an int is a then index into the stars array. Bool and not in tree. Okay, and I'm going to initialize points not in tree with everything. So range stars, points not in tree, I equals true. Then what I'm going to do is for len points not in tree greater than 0. And actually what I'm going to do is I'm going to do points in tree of 0 true. Of the edges that connect the tree to point 0 tree is true, and oh wait, I don't know how to do this. Delete, use the built-in delete. Okay. Tree delete Okay, so for len points not in tree is greater than 0, min in index, min out index. For any range points in tree for outie. Yes, I have been watching Severance. So range, any, and outie. If distances any outie less than min dist, then min index is any, min is outie, min dist is distances any outie. Okay, and then what I do is I do okay, and we're going to need to know the total tree size. This size is the edge-length. That's, yeah, total edge-length, and then here we say delete points not in tree min points in tree true spanning tree edge length plus equals min dist, and I guess we don't actually need that. And then here we return tree edge len plus len points in tree. And this will then be okay. Looks good to me. Let's go run quest 17. 59. Whoops. What? Really? Okay, so let's try this input. Copy that. Let's Let's try that input and let's file, save as P1 samp. Okay, so okay, so we're gonna try it here. Oh, of course. Samp. That says 16. What is the size of the constellation created from all the stars in your part of the sky? Okay, so it says 59. And the thing is saying that that is incorrect. Which is weird because I'm pretty sure okay, so let's test this out. Let's because, you know, I have as a human, I can look at this and I can see, oh wait, that's simple. I can see, okay, we're going to end up with here this this thing going out here in the middle, kind of like spokes on a wheel. And then this and this going like that. So I'm going to try to see what's going on here. Yeah, I'm going to try to see what's going on here by printing out edge from stars bracket here. So I do actually need this. I need min in IDX min in IDX equals any stars in 2 stars min out of X length min dist. Okay. So I do set min dist, and we do set these, and yeah, I don't see what's going on here. Okay, so let's see what we have here. We've got a thing from 512 to 912. 5. Really? Row 5, character 12? Wait a second. Am I reading the right input? I am not. Ah. And because all I cared is if I had a... That's why it worked fine in the sample code, because then the sample code I was explicitly passing in the input file. So that was my mistake. 135. Yep. Oops. Part 2, exactly the same. But much bigger. Okay, remove this debug statement. And then we also have to remove that. I understand why Go does it, but I gotta say, I don't think I'm a fan of the, oh, we're going to make it an error to not use a variable thing. I just don't, I'm just not really a fan of that. Okay, so for part 2, we're basically doing part 1 with different data. So 1, 2, 1, 4. Yep. Part 3, a brilliant constellation. Regular distance between connected stars must be less than 6. 2 stars for separate brilliant constellations. Brilliant constellations, and they're given fragments. The 3 largest brilliant constellations and multiply their sizes to get the final answer. Okay, so distance between connected stars must be less than 6. Okay, so this is basically the same. I just gotta bust these stars into groups. Each of them each of them 6 or more apart. Yeah. Okay. So what I'm going to do is I'm going to, first of all, close that. I'm going to take the core of problem 1 out as a separate function and let it be okay. And then this is going to be, actually, no, I want to here. Copy, paste. And what I'm going to do here is I'm going to copy. I'm going to refactor this into a extract function. Okay, a new function, and the new function is called constellation size. Nope. Do I have a... Shoot, I was hoping it would have an inline. Yeah, inline function or something. Okay, so that takes care of that. Now what I'm going to do is I'm going to go through, I'm going to find all the stars, and I'm going to split them up. Copy. There. Okay, so we have that. Now, now what I need to do is I need to split the stars up. So what I'm going to do is I'm going to so these are star category. Star category will be a map from point to int, and I will initialize star category with everything in the stars. Sorry if my HVAC is showing up on the screen, or showing up on the stream. It's a little loud. Star, and then here what I'm going to what I actually do want the index, because I'm going to initialize star category for each star with a different index. And now what I'm going to do is done is false for, I keep typing while. Someday I will stop typing while. For not done, done, for not done, done equals true. For star A, okay, and now I want to do pairs of stars. So actually what I want to do is I want to do for yeah, star A, range stars for star B, range stars, bracket, star A there, star B there. If you know what, I need I probably don't need this as a function. Stardust. These, what do I call these? Star A and star B. Star B, star A, star B, star A, star B, star A. If star dist. Now, are these less than 6 or less than or equal to? Must be less than 6. Star dist is less than 6. I'm not in Python, come on. If star dist is less than 6, then star category of star A is equal to min of star category star A star category star B star category star B star category star A done equals false, and eagle-eyed viewers will note I missed a condition here, and star category of star A okay, done is false. So yeah, that should take care of it. And then once that's all done, we do constellation holder make map from int to slicer point. For range star category, constellation holder cat equals append point. Now these will be sizes. For range constellation holder, sizes, oh whoops, yeah, dot append sizes, what did I call this, constellation size of star array, then okay, slices dot sort sizes, and then I want the 3 largest, so sizes, actually yeah, whatever. Sizes bracket len sizes -1, conf.I to A. Okay. Product. Did I already get part 3? Yes, I did. Did I already move it over? I don't know. Okay, that's kind of big, but that's kind of what I expected. Yay! Okay, so Quest 17 is done. And I learned a spanning tree algorithm that I will try to keep in my back pocket for next time I need to construct a spanning tree. It's not that bad. You just get that and that. And I also learned make your skeleton ahead of time so that you set up the in files correctly and aren't doing it while you're trying to start up the problem, because otherwise you do it wrong. And you forget to update your input file. So, yeah. Okay, I'm going to stop this, and maybe I will also put up a screencast of Quest 18. We'll see.